Hi, and welcome to Talking Tech. I'm your host, Alejandro Hoyos, and I am very excited as we're going to be talking about Intel's latest processor, Meteor Lake. We have gone from a monolithic die to a completely disaggregated multi-tile, which is Meteor Lake. What have been some of the greatest challenges you've run into?
In Meteor Lake?
Yeah, in Meteor Lake.
Okay, so when I think about the Meteor Lake, sure, this is going to be one of the best products, I would say, that will catapult us to the top again. But in my mind, Meteor Lake is not just the name of a product. In my humble opinion, Meteor Lake is the name of an experience. As I'm talking to this, I'm actually getting goosebumps, believe it or not. The reason why I say that Meteor Lake is the name of an experience because the experience was unique and extraordinary in so many different ways. Let me walk you through. There was challenges on the design side, the architectural side, the complexity-wise. It's a grounds-up design. We are putting NPU, we are putting this, we are putting that. So we're engineers, that's what we do, we solve problems.
How to balance between these different tiles that we have, right? There's a compute tile, SOC tile. When do we move the work? What are the efficiency points? How does it react to one workload that we are running versus other workload that we run? We constantly have these trade-off decisions, right? Because you cannot have an algorithm that works 100% right all the time for all workloads. There are corner cases that we hit into, and we have to then make the trade-off decisions. And it's not just thread director. This happens in power management flows, OS decisions, everything. We don't want to also give too many changes to OS, right? Because they have to react to it. And there is overhead to move work. So how do we balance that? That overhead becomes less. We are not actually hurting anything when we do that, right? So those were kind of the points. And a lot of very smart people contributed to this to make it work together.
Working with TD, the initial challenges were in achieving the power and performance characteristics we were expecting. There were initial challenges at the beginning of the first stepping, but over the course of the last 6 months, with the strong collaboration between TD and design, using the principles of IDM that we are co-located, we've been able to bring up the performance of Intel 4 to where it needs to be, and you should be able to see it when we launch Meteor Lake.
Technical challenges, if we start with, right, when we had our the new process, we had these external customer PHYs that we were trying, like HSIO space. Let's talk about HSIO space. We had to marry the external PHYs with the internal Intel controllers. And when you put that together, we had to ensure we still give the same customer experience. It's a new process, but hey, the customer needs what they're used to, what they need all the time. So we were able to go, and for PCIe, we were able to put them together and get a very, I would say, seamless customer experience going for the team. And at the same time, we were able to get the nuances or the details that we wanted so that we could grow on innovation there, which meant we were able to get to PCI Gen 5. We were able to do UFS Gear 4. PCI Gen 5, it's the first time we did that on a mobile segment. So that was like,
That's a big win. That's a big win right there.
For sure for us.
All the interfaces, which each die is a new protocol, right, which we had to validate, test, right? We made sure that all our interfaces were fully verified, right? We made them all verifiable interfaces, right? So a lot of work, a lot of architecture innovation went in. The power management was revamped. Every IP had its own power management agent, which talked to the P unit.
Also, at the same time, figuring out the power management flows, because bear in mind, before Meteor Lake, we didn't have this many tiles, right? So now all of a sudden you're going to figure out how does the power management on the north talk to the south, to the IOEs and to the CDI. And so it's interesting. It's challenging.
One of the key things for Meteor Lake, among many others, was die-level disaggregation. But what also happened to increase the complexity and the challenge quite a bit is usually when you have all these various IPs revving, you would count on the fabric being pretty stable. But this time around, given in the previous generation, which was Tiger Lake, right, we had maxed out the bandwidth capabilities of the previous fabric, which was PSF. We had to make a transition to a new fabric, which is what the NOC or the network on chip fabric was. So the product landing zone, bandwidth requirements called for that jump, but it was happening all at once, right? So you're changing the fabric and you're also revving all the IPs along with it. There are all these various protocols that these agents come with, like the VPU. So there's protocol translation, there is all this bandwidth flowing through the system. So it all happened all at once, and there was more complexity layered in on top of it. So that's what made this extremely challenging, but fun too.
So not only you require the bandwidth and also the speed for it, also when it comes like a physical level, you have to take into account all the traces that you have to build. So that's another level of challenge.
Correct. And and that added an extremely complicated challenge on top of the new fabric, right? Which is we had cost becoming a big issue. And with DISAG and the cost associated with Foveros, right? How do you get the entire product to still be cost effective? So the floor plan constraints, the die size constraints, the utilization push was unlike anything we have done before, right? So we were trying to hit best in class with our competitors in terms of utilization of the various blocks in the die. And the floor plan is a big puzzle fit because every IP, like a display or a media, etc., has a certain aspect ratio it likes for its content. So then it becomes this, everybody wants to stay close to memory for bandwidth latency, but then you can only fit the puzzle so many ways. And the chassis then is what it is. And you have all these distances to travel, repeater hops, adds latency. And, so it was this multi-vectored problem.
And then to make sure that when you put it all together, it's like, all right, let's make sure that, are you working? Are you working? Are you working?
Exactly. I mean, when we are putting everything together, something doesn't look right with these few bits of a bus. What went wrong? I mean, did we make a wrong connection? What did we do? So then you have to debug, onion peel, and then you figure out, there was a modeling error, or there was something wrong with the stitching or the extraction, right? And so which we fixed that, and then we ran again.
And one of the biggest challenges is the void during the epoxy process, creating the void. So what we do is we fine-tune the process. We're adding in the high-pressure oven to make sure that we drive the void, a reduction or elim, to make sure that we do not have any void issues at epoxy operation, right? So that is one for assembly. And secondly, for tests, there are a lot of challenges because this process, we are focusing a lot on time to market as well, right? We need to make sure that we have the collateral up the production on time, the test program release on time to make sure that we'll be able to test this product at high volume manufacturing with the best quality.
As we started Meteor Lake journey, we got hit by this pandemic. Okay, no one knew as to how we'd respond to this pandemic. While the pandemic was happening, we are going full speed ahead with the Meteor Lake execution.
I say Meteor Lake is a COVID child. It was born and raised through COVID, right?
I recall, a bunch of us kicking off the project towards the end of Q4 2019. And personally, I was thinking that, oh my gosh, such a big and exciting project, multi-team, cross-geos. There's bound to be a lot of travel involved.
Even communicating, because you can't see each other in person anymore. Everything was home environment, right? Kids were in parents' labs.
So you guys kick it off 2019, COVID hits, so everybody has to stay home, work from home, which makes it very challenging because the teams are across the world.
Across the world, many new collaborations, new teams coming together, especially like in the SOC, you have the North and the South, and North is coming from DDG, South is from CSG, and we have to figure out a way to work together as a team, collaborate, and just make it happen.
The complexity, the technical complexity is something we as engineers love, right? It gives us that motivation, the challenge, to be able to do better, to innovate, brings a lot of excitement. COVID is something that we had just not anticipated.
As engineers, you're being trained to, okay, this is how we design, this is how we execute, this is how we validate. But now you have to do all this with your, like you said, with your kid in your lab.
Literally,
Mom, play with me, play with me, play with me.
Yes. Shweta's kids, they know all our names now, right? Yes. And that has been the case. Pretty much all kids know at least the names of the team members that their parents work closely with, right? And there is a level of camaraderie that comes with it. There's a level of closeness, right? That we may not have had before, and the bonds have definitely become stronger. So in some ways, we've become a better team, better organization, better Intel, I would say.
COVID-19 definitely hit everyone hard, especially the factory that we need people to work on site. We pick up the remote training and learning from TD to make sure that we have a good collaboration with TD, with division team to make sure that we deliver this product on time. So we kind of, knowing the risks that we are facing, we come up with a contingency plan, we come up a new way of doing business to get things going.
It is just simply amazing as to how Intel, right, each of our small teams, the bigger teams, right, bigger multi-organizations came together.
At the end of the day, this team rose to the occasion and we delivered this in style. And I will tell you that, as we executed this journey, there was absolutely no shortage of risk-taking. There is no dearth of innovation. There is no paucity of collaboration across different groups, different geos. And at the end, I would say that we delivered this.
And this drives, us to look for ways of standardization. And I think this is a good step so that we are more efficient moving forward into the next projects.
Yeah, that makes sense because now all the learnings that you got from Meteor Lake, you want to apply for future products.
Into the future products and across different teams. With standardization, it really doesn't matter which die you put together, which team you work with. And I think that is how we become more efficient as a company.
We've all given a lot, right? And you come to love and feel passionate about it when you give that much. And I'm just a small cog in the wheel. But yeah, super happy to be there.